So we learned how to calculate the pH from the hydrogen ion concentration. So that was this equation here. What if we know what the pH is, but we want to know the hydrogen ion concentration? So this is the equation for that. 10 to the negative pH is equal to the hydrogen ion concentration. Let me just show you how that happens real quick. So pH equals negative log of the hydrogen ion concentration. So if we're going to solve that for hydrogen ion concentration or hydronium ion concentration, we need to get rid of this negative log business. Now, log is a function. You can't just divide by it. You have to do the opposite. This negative sign is just multiplying by -1. So let's get rid of that first. We'll just multiply both sides by -1. Now we have negative pH is equal to the log of the hydronium ion concentration. The opposite of log is antilog. Antilog is 10 to the x. So we'll do 10 to the x of both sides. That gives us 10 to the negative pH. And 10 to the x of log, just poof, it's like matter and antimatter. They just disappear, and we get hydronium ion concentration. So for those of you that are interested, that's where that comes from. So this is a very important equation. pH is the negative base 10 logarithm for the hydronium ion concentration. So let's try that out. Calculate the hydronium ion concentration for a solution with a pH of 8.37. So we're given that pH equals 8.37. And we want to know what the hydronium ion concentration is. This has to be done with the equation. So the hydronium ion concentration is equal to 10 to the negative pH. So that's 10 raised to the negative 8.37 power. Now, we don't see numbers like that as exponents very often, but your calculator is just fine with it. So you need to learn how to talk to your calculator to do this calculation. I have the TI-36X Pro, and so what I do to calculate this is I press there's a button that has E with a square and 10 with a square. That's not a square. So this is what's on my button. And if I push that once, I get E raised to a power. If I push that same button again, I get 10 raised to the power. And then I put in negative 8.37 and press enter. Okay, and that gives me 4.3 times 10 to the minus 9. And the unit on that is always going to be molarity. Units get a little weird with logarithms. Any questions? Make sure that you can get your calculator to give you that number. Yeah. This button with the E in the square, you push it twice.
And then for the log, it's the same.
Oh, for the log, it's the same. Yeah. So on the TI-36X Pro, natural log and logarithm are on the same button. If you push it once, you get natural log. If you push it again, it'll show you base 10 log. If they're on two separate buttons, some calculators you're going to have to press the function button first to get the log. A lot of calculators have log and anti-log as different parts of the same button, and then they'll have natural log and anti-natural log on the same button. So the other number that we sometimes, or the other thing we sometimes calculate is the POH, the hydroxide ion concentration. So just like pH is the negative log of the hydronium ion concentration, POH is the negative log of the hydroxide ion concentration. Because P in front of something means negative log of. You could also have a P calcium, which would be the negative log of the calcium ion concentration. There actually is a very simple relationship between pH and POH. So we learned that the hydronium ion concentration times the hydroxide ion concentration was equal to 10 to the minus 14. If we take the base 10 log of this, when you take the logarithm of numbers that are multiplied, then you add. So if we take the log of both sides, we're going to get the log of hydronium ion concentration plus the log of the hydroxide ion concentration. And what is the log of 10 to the minus 14? Minus 14. Because taking the log is asking, what power of 10 is this number equal to? It's equal to 10 to the negative 14. If I want this to be pH, I need the negative log, right? So I'm going to multiply the whole thing by negative 1. So that makes this a negative, and that makes, that makes this a negative, and that makes this a positive. Negative log of hydronium ion concentration is pH. Negative log of hydroxide ion concentration is POH. pH plus the POH equals 14. If you didn't follow the derivation, don't worry about it. This is a useful thing, and this is also useful. So I'm going to show you the circle of pH. It's a little bit like the circle of life, but without the lions and the music. Okay, so our basic relationship is that pH equals the negative log, wait a minute, started wrong. We've got pH and we've got hydronium ion concentration, and we've got hydroxide ion concentration, and we've got POH. We can calculate between pH and hydronium ion concentration. Oh, good grief. See what I did there? I'm just throwing 3's around like they're nothing. There's no 3 there. We can go between the hydronium ion and the hydroxide ion concentration. We can go between hydroxide and POH, and we can also go between pH and POH. So the relationship between pH and POH is the simplest. pH plus POH equals 14. The relationship between hydronium ion concentration and hydroxide ion concentration, they multiply together to equal 10 to the minus 14. Converting between pH and hydronium, the pH is the negative log of the hydronium ion concentration. The hydronium ion concentration equals 10 raised to the power of the negative pH. And then the relationships down here mirror the relationships for the hydronium ion concentration. And there you have it, the circle of pH. That one actually turned out pretty good. I'll have to save that one. So those are the relationships involved in pH. Any questions? If you want a nice copy of the screen, you can go to the YouTube video, pause it there, and take a screenshot. I'll give you a real nice copy of it. Make sure I didn't miss a slide. Okay, so then this is asking us to calculate the hydroxide ion concentration for a solution with a POH of 4.25. So this is very much like doing the hydronium ion concentration from the pH. Hydroxide ion concentration will equal 10 raised to the negative POH. We're given POH here. So that's going to equal 10 to the negative 4.25 power. So make sure that your calculator is cooperating. And my calculator is showing me 5.6 times 10 to the minus 5, and the units would be capital M, molarity, moles per liter. Get your calculator to show you that. So a Casio or a Sharp, most likely, or one of the simpler TIs, most likely you're going to have to put in 4.25, change the sign, and then press the 10 to the X button. Other calculators, you'll do 10 to the X, negative 4.25, and press enter.